Hello everyone. In this video, we will introduce the notion of equiprobable sample spaces. So these are the sample spaces which will make our life much easier while trying to compute probabilities of different events. Well, let me just get into it and give you the definition. A sample space of an experiment is called equiprobable if every sample point, remember sample points are the elements of the sample space, every sample point is equally likely to occur. So they all have the same probabilities. Why these are important, we will see it later, but for now, let's just see in different examples of equiprobable sample spaces. Okay, let me start with the experiment of rolling a die. So roll a die. And you know that we can have different sample spaces. For example, one of the sample spaces that we learned to work with is 1, 2, 3, the list of the numbers that come up when you roll the die. And, well, since the sides of the fair die are equal, and then everything is so that all the sides will come up equally, that means that probability of one comes up is the same as probability of two comes up. And actually, one way to see this, other than intuitive way of seeing this, is that, okay, I can simply relabel the sides and still the chance of getting the numbers will be the same thing. And that is why die is used for choosing a random number fairly, yes, between 1 and 6. So that means that all sample points, these guys are sample point in this case, all these sample points are equally likely to occur. So that means that S1 is an equiprobable sample space. Well, we can have other sample spaces for this experiment. For example, I can have this one. The number that comes up is greater than 2. The number is less than equal to 2. So is this an equiprobable sample space? Well, to decide if it is equiprobable or not, we have to see how likely the first sample point is to occur, and how about the second one? Are these equal or not? To determine that, one way, and you will see that we will repeat this over and over again, if you have big enough equiprobable sample space, in this case we already have the list of all possible outcomes, 1, 2, 3 up to 6. This was an equiprobable sample space. Now I can use those ones and list the sample points of S2 as events of S1. So here means that I get either 3, 4, 5, or 6. Here it means that I get either 1 or 2. And when you look at this thing, again, you don't need to have much of mathematical background. Intuitively, the chance that you get 4 different numbers on the die is way bigger than probability of getting only 2 numbers, 1 and 2. Okay, and that means that no, S2 is not an equiprobable sample space. And while the examples will come very similar way, I have another example here that this time a die is rolled twice, and now we have following sample spaces. There are two here. We want to see if they are equiprobable or not. The first one is just listing all the possible outcomes. Here is the first roll, and this is second roll. And then there are 36 possibilities, and we have rolled out all of them. This means that with again a little bit of intuitive thinking, that the probability of getting any two different numbers or equal all the possibilities are going to be the same thing. And one of the ideas I would like to use to make this intuition stronger is again relabeling the sides wouldn't change the probability. So that means that if I have all list of all the outcomes here, they will have the same probability. So S1 is yes, and equiprobable sample space. How about S2? S2 is sub is equal to 2. So you have two numbers, you add them, they add up to 2, to 3, to 4, 5, 6, up to 12. Can we decide that this is equiprobable or not? So we have to come up with an idea showing that they are or are not equally likely to occur. Again, here, since we have a large enough equiprobable sample space, we can write sample points of S2 as evens of S1. So to sum to get to add up to 2, we only outcome that will give us is 1, 1. How about 3? Here we can have either 1, 2 or 2, 1. How about 4? Well, for 4, I will get either 3, 1, 2, 2, 2, 2, or 1, 3. And this goes on and on. Yes, for 12, you get only one element. But just by looking at these two things, so probability of sum is 2 is something that will come out only from one of these outcomes, and probability of sum is 3 will come out from two of these guys. Probability of sum is 4 will come out from 3 of these guys. So as you can see, this has larger probability. Well, there are more possibilities to get sum 4 than to get sum 3 or to get sum 2. Okay, so this means that obviously S2 is not equiprobable. And as I said in different video, I will show why these equiprobable sample spaces are good sample space and how they can help us to evaluate the probabilities of events.